going to do, I think we'll try probably 2 more of these. And then one of them will be part way, the other one will finish. But it only makes sense, so we just solved the very first equation that we solved in this class. Why not solve this, this second equation? So what if we do that? Let's try this here. So we're going to solve y prime equals ay plus q. And we're going to put a condition on this. When a and q are constant. I should say solve by separation. And you have to be just a little bit more creative to do this. So let's think about our form. So let's clean this up. We have this on the left, we have dy dt. And on the right, notice I want this as a function of y and a function of t. And I don't even have t in this problem, but it's still worth factoring. Let's factor this out, factor the a out of the problem. So I'm going to write this as a times y plus q over a. And again, we're kind of in a similar situation that we were just in. So we can solve this as 1 over y plus q over a dy equals a dt. You could have. You could have put the whole thing over 1 and you could have had y here, but then you're going to want to make some kind of u substitution for the natural log. So that just makes the problem harder. So you could take that route. This just seems a little tricky. All right, take the integral of both sides. So we're going to take the integral of 1 over y plus q over a dy. And we're going to do this, our limits are from y to 0 to y to t. And this is going to equal the integral from 0 to t. And we should be changing this to we use our dummy variable dx. Then, on the right-hand side, so what we have is we have the natural log of y plus, of y of t plus q over a minus the natural log of y of 0 plus q over a. Equals, what do we have? On the right, we have a t. Okay, we're going to add this second term on the left, add it to the right. Remember our goal. Remember our goal is to solve for y. And then we will. Yeah, you could turn this into a division problem. Is that what you're thinking? Yeah. You know, you could do it that way. Do you want to take that route? I wasn't planning on it. Would you guys rather do that? Yeah. So first, let me ask a good question. There's a property of logarithms right here. So recognize what it is. It's division. You could also write the natural log of this quotient of y plus q over a over y of 0 plus q of a, and solve it that way. In the end, it should work as well. But we'll just go the way of natural log. But that was clever, right? You should try it too after this. Equals natural log of y of 0 plus q over a plus a. And what do we have? Raise both sides to the e, and so we're on the left-hand side. It cleans up pretty quick. We get y plus q over a. But on the right-hand side, we have this humongous piece, and I'll write it out. We'll clean it up. It's a to the, or I'm sorry, e raised to the natural log of y of 0 plus q over a plus at. So let's clean this up and write this as y equals. We're going to do a couple things. First, we're going to write this as e natural log y of 0 plus q over a e a. Oh, minus q over a. Oh, do you see it? It's there right in front of us. Look at this. If we apply our properties of E, so we have y equals, oh, I like this. Y of 0, I'll put this in parentheses, y of 0 plus q over a times e to the at minus q over a. Oh, this is great. Look at what we have. Look at what we have. This is that exact same thing. So you can see if you've done this, even using indefinite integrals, you would arrive at c, e to the at, minus q over a. That would have given you the c. Exact same result. And here it is, all nicely laid out for you. Okay. Let's see. We need to set up. We need to find one more problem. Did it work?
Yeah, it's like way quicker to do
Was it?
once you do it. Yeah,
Way quicker?
like 2 steps instead of.
Oh. Really?
Yeah.
I feel like I wasted your time. See, even it's the curiosity. Look at what that started. See, now you're all the richer. All right, let's do one more. This one will look a little bit more interesting. And that is this. We're going to solve by separation. Solve y prime equals 2 times t times y. Now, this one I believe, let me get this book real quick. Yeah, I think we've seen this one before, haven't we? We have. It's on page 2. Let's see if we can get the answer now. Let's see if we can do this. Okay. So, the first thing is we're going to solve that, and we're going to use separation. So I'm going to make that note. Use separation. Separation. So first, let's start out. And I think this is just a good habit. If you find a faster way, that's fine. But when we get into our next step here today, it really helps to have written this step out. dy dt equals 2 times t times y. So the problem with this is that we have a 2 really isn't a concern, but we have a t times y. Remember, our problem has to be written as all the y's dy on one side, all the t's dt on the other side. So take a moment and see if you can separate this so you have the y's and the dy on one side, the t's and the dt's on the other side. So just
Assuming y not 0.
yes, y is not 0. Because if it was 0, then dy dt equals 0 and the answer is 5. Good question. No, that's always a good concern. And that was actually something else I wanted to address today too, so remember that. Victor had a great question. So here's what I would do. We know we're going to put the dt on the right. So let's do that. We're going to put a dt on the right. We want our y's on the left. So let's write this as 1 over y dy is equal to 2t. And then let's take the integral of both sides. So we'll take that. We have the integral. Y is 0. I do. Thank you. dt. That's better. 1 over y dy equals integral from 0 2t. I guess I mean, tries to be correct on my variables as the 2s dx. Okay, integrate. Get a natural log. Natural log of anticipating a big one, but it's not. It's the natural log of y minus the natural log y is 0. It's equal to, is that just a t squared? T squared. Okay, let's do that. T squared. Let's move our natural log over to the other side. Or, you know what? Let's try this again. Let's try Marceline recognition identities here. This is just the natural log. I've never done it this route. So prepare for, I would make sure you keep that eraser handy. This is y over y of 0. There's t squared. Raise both sides to the e, and so I have y over, this is y of 0 is equal to e the t squared. And there's our answer, y equals y of 0 e. Nice. Good job. I've never done it that way before. That was really clean. I've become a creature of habit. All right, let's do this. Part 2. Exact differential equations.